So to kick off the short paper presentations that we will be having now, we have Rynhardt Kruger, who is from the same lab that I am, although he's not my student, and he will be telling us about how blind people can actually navigate and use a virtual environment, which is a segment of the population we don't generally think of when we think about MMPEs. So, Rynhardt.
Thank you. I usually ask, can everybody see me, because I can't see you?
We do.
Good. I take it as a yes. So, what I am going to talk about is how to make a virtual world like Second Life and OpenSim-based worlds accessible to the visually impaired. This is necessary for a number of reasons. The one reason is not to exclude blind people, because there are about 45 million of them. Also, especially in Second Life, there's quite a few disability communities, but not blindness communities, because there's not really accessible clients for Second Life for blind people. So, if you want to make a virtual world accessible, you have to find an alternative rendering method than the graphical rendering normally used for such things. You can either do this in a hardware or software way. There's been some work done on hardware devices. One paper described a system where you use two fingers to, they basically built a device which enables you to use two fingers to explore three-dimensional objects. The problem with hardware devices, though, is that the user will need to acquire hardware devices. And for a segment of the population, you don't usually have a computer mouse. They're not going to acquire more hardware devices. If you use a software solution, then you must use whatever alternative is available on the system the software is running on. And this is usually audio. Some authors have discussed using text, but if you use text, the blind person reads text by using speech synthesis. So therefore, it's basically audio as well. Then the problem with audio is that it's not like a visual display where you can move your eyes around and do whatever you're interested in. Audio is kind of whatever you throw at someone's ears, they are going to hear. So you need to break it up into small pieces of information to be easily processed. And the way it's I discussed doing it is by using navigational, by using tools, basically commands and exploration tools and navigational tools to read whatever you need to read, hear whatever information you need at a certain time when you need it, not continuously. It's not continuously displayed like the graphic system. So what I've developed as a client for Second Life and OpenSim-based worlds. This client serves a number of purposes. In the first place, it makes these worlds accessible by using audio as a medium and by using tools to break down the audio channel into manageable pieces. It also serves as a framework to test these tools, to basically compare them. There have been a number of tools described in the literature, and also I've developed some myself, which I will talk about just now. But the question is, what tools do you use? What information is needed? So this framework, this client allows you to enable and disable tools and plug them in and basically to evaluate them, which I'm going to do in the very near future, user evaluation using this client. Some of the tools used by the client include what I call a spatial speech module. What this does is the name of each object in a certain way is spoken by synthesized speech, and it's spoken using 3D audio at the position of the object. Now, I'm not sure how many people are familiar with 3D audio. Basically, you can position a sound in 3D space, and using either headphones or surround sound, the user can get quite a good idea of where the sound actually is. So I use spatial 3D audio to position these names of the objects, and the closer the object is, the longer time the name is played. This gives you the effect that objects near to you is easily distinguishable, but the farther away the object is, the shorter the actual sound clip, which means that you can effectively zoom into objects by going closer to them. There's also a grid explorer, which basically breaks the region up into cells. It's like a spreadsheet, but in 3 dimensions. This you can increase or decrease the cells and therefore increase or decrease your resolution of exploration. This works quite well for giving an overview of the region before you actually visit some area, because just like real life, it just works better when you know the area before you go there. I think the next slide is an example of the Grid Explorer. There's also a module which uses narrowband noise to indicate open spaces. The idea is if you walk, let's say, down a hallway and there's a branching corridor to your left, when you pass the branching corridor, you will hear narrowband noise play to your left, which indicate that's an open space, which aids in navigation. And then there's also a tool for cycling between objects around you, either right or left. So you can either, by pressing a key, turn right to face the next object in that direction, or turn left to face the next object in that direction, which can give you an idea of what's around you and helps you to interact with the objects. Finally, this client, I think this is the last slide, I developed. I will use this to suggest some improvements to the OpenSim API to make accessibility easier. How it's usually done with like 2D graphical components is there's an accessibility API which enables screen readers to more easily get the information they need. And I think such a thing is necessary for virtual worlds as well, especially because there's information now which a client is not able to get from the server, but which is actually quite unnecessary for effective accessibility. One example is to get the distance between two objects, effectively the distance between their edges. This is not possible using the API at the moment. You can do it by calculating the edges yourself, but then you should hope that your algorithm is the same as the one used on the server, which is not usually, well, it's not necessarily the case. That's one example. Another example is to get more semantic information about an area. Let's say this room is in the virtual world. By just looking at the objects, I will know that there's a wall, and there's a wall, and there's a wall. But I won't necessarily know that this is a conference room, or that I'm in the conference room, which is information that all developers should be able to tag or use to indicate by using tags or similar methods, and which can then be deduced by accessible clients. Yes, and that's basically it. Thank you.
Any questions or comments for Rynhardt? I mean, I think people are usually trying to remove information you're trying to send the client, and he's actually asking that more should be added. Philippe, here is a microphone.
So I'm wondering how you navigate. You said you can navigate with just with a cursor or something, with a keyboard. So I'm wondering if there aren't easier ways to navigate. For example, some kind of head tracking. There are accurate head tracking devices coming out, and this might be interesting even for blind people, because you could just look at certain direction and then something will be read to you what you would see in this direction, so you do not have to say, okay, go right, go left, look right, look left. You could just move your head, and this is maybe an easier way of interaction. Have you looked in that direction, or do you know of any works in that direction?
This is a very viable option you are describing. Both head tracking, and I've also thought about a touch screen interaction, just touching the area you want to see. In this research, however, I tried not to use any additional hardware devices, specifically because the idea is that the blind person can just fire up the client and connect, just like a sighted person. It's not to acquire any additional hardware devices. It will make it easier, you are right. What it will also do is it will aid with the 3D audio, because in real life you move your head slightly to judge whether a sound is behind or in front of you, which obviously can't happen just by headphones, but with a head tracking device it can. This is definitely something that can be added to the client for people who own a head tracking device, but I haven't added it, no.
Okay, thanks.
Joachim.
Another question. Have you thought of having an audio sonar, something like generate, because the 3D information actually is there and is sent then to the graphical card in OpenGL be represented. So I think it could be used for generate the 3D sound. If you have, for example, a sonar, make a little sound, and the reflection of this sound will help mapping the environment.
There is actually one of the tools currently in the client is a sonar which identifies the objects around you. It doesn't indicate the 3D shape of the objects. It's a bit difficult to do this. One of the reasons is that blind people are not trained to recognize 3D objects from 2D flat descriptions, if I can put it that way. That's something you are usually, which a sighted person can do intuitively. Just for interest's sake, we have many times looked at 2D tactile graphics, tactile depictions of objects, but it's difficult to deduce exactly what object that is, because your brain isn't trained to remember that information. It's an interesting an option, and definitely something that can be investigated, but I try to focus mainly on semantic information for now.
Okay, thank you very much. Okay, thank you, Rynhardt, and thank you very much. And I'll ask the next speaker to come forward, Salon, and here is the next speaker.